Hey everyone, so today we're going to be solving Leetcode 2825 and this is actually today's problem of the day, and yeah, let's try to solve it. So we're given a zero index string str1 and str2, and we need to prove that str2 is a subsequence of str1. Okay, the option that is given to you is that you can increase, at most you can increase the value of one of the characters by 1, and it should be done cyclically, meaning that when you reach z you need to increment it to a instead of incrementing it to the next ASCII value, right? So that is what cyclically means, and you need to prove that AD is a subsequence of ABC. Okay, now before we get into the problem, let's understand what is a subsequence. So let's say that we have ABC is the first this thing, and then AD is the second one. Let's actually make it AD. Okay, see, this is a subsequence because this entire sequence is present in this particular string. That's what subsequence means. But what if I tell you that the string looks like this? Is it still a subsequence? Yes, it is still subsequence because you have these two characters coming up in the main string, and also the relative position of these characters is maintained in the parent string. Okay, so it is still a subsequence. Let's take another example of this. D, A and C is a subsequence. This is not a subsequence because though all the characters of AD is present in DA, it's not in the relative position of AD, right? Because D is coming before A, and in this case D is coming after A, so it's not the same. So ideally, let's say that if it's given you that even the relative position of the string does not matter, ideally what we would do is we can maybe create a set, add these two elements in the set, and then maybe iterate through the parent string, and then check if the elements in the set are present in the string or not. But since the relative position of the order has to be maintained, the hash map or hash set approach would not be feasible because you would not know the relative position of the elements, right? So that is why we need to think of something different, right? So let us think about the approach to this. But before that, let's go through the constraints. So every time whenever you're solving a problem, you always need to go through the constraints, because that is what would tell you what kind of approach you need to follow for the problem, right? Here it's mentioned that string 1 dot length is 10 power 5 and string 2 dot length is 10 power 5, right? So if you take the worst case, that is, let's say that I'm iterating through both the array at once. So by that what I mean is, let's say that I'm iterating through this one, okay, I'm iterating to this one, and then I'm checking if A is present, okay, in the entire array, right? Then what I do is I take D, and wherever A was present, from there I would return that position to the parent loop, and then I would iterate from A to through the entire array to reach D, right? To reach D, and if D is found, I would return and then once I come out of this, I would need to have some kind of flag which tells me that okay, till now we have found it, and then that would return true or false. Okay, now what is the worst case of this? Let's say that the string 1 dot length is 10 power 5, okay, on the worst case, and string 2 dot length is also 10 power 5. So ideally you would be applying loop on both the sides, and then you would be iterating through on the worst case, you would be iterating through each and every element on both the sides, right? So the worst case complexity would be n square. Okay, n square, let's take n as 10 power 5 and then 10 power 5. So our final complexity would be 10 power 10, right? For the brute force approach of n square, our time complexity would be 10 power 10, right? Now tell me something. If it's 10 power 10, so our entire algorithm would take 10 power 10 iterations. 10 power 10 iterations to run. Is that feasible, right? It's not. I mean, with octa-core or any other processor that is we get nowadays, yeah, it is possible. But let's take a single core. It cannot process instructions at 10 power, which goes up to 10 power 10, right? So if all the editors that you see currently, Leetcode, Geeks for Geeks, anything, would have a constraint limit. So if your, let's say, number of instructions is going out about 10 past 6, or 10 past 6, ideally anything more than 10 past 6, it would give you a TLE. I would say that it would wait for some time. If within that time the entire logic is not processed, then it'll throw you TLE, right? So if you're getting an approach of 10 part 10 and you have 10 past 6, 10 part 10, in that case this would throw you a TLE, right? So now we know for a fact brute force cannot be applied. But when you're going through the problem, when you're doing the when you're trying to get the intuition for the problem, I would suggest you to do the brute force approach, then go to the optimized approach. Only then you will understand what the problem is. Okay, now let us try to look at the optimized approach. Okay, so let's take an example. Let's take two examples actually. One with one where it is true and one where it is false. Okay, and 80. This is string 1 and this is string 2. Okay, what is the approach that I can use which maintains the relative order of the which maintains the relative position of string 2 such that it forms a subsequence in string 1? Okay, what I can do is, can I not set two pointers over here, pointer I and pointer j, these two, and increment it based on if the value is found or not, right? So the approach today, the approach for this problem we'll be going for is two pointers, right? We would two pointers. See, the thing is, two pointers is easy. It's easy to come up with a solution, but you need to be very, very, very careful in terms of how you're going to increment the pointer based on the result that you found. Okay, so what I mean by that is, let's go into this problem. Let's take I and j. Okay, let's see. Okay, yeah. Let me copy this down here and expand this. Okay. Okay. Now, is the value of I and j equal? Yes, it is equal. Okay. So now we know that it is a subsequence. So now we know that subsequence may exist. Let me correct it. I do not know for a fact it is a subsequence. I'm just telling you subsequence may exist. Okay. Now what I'm going to do is, I'm going to increment both the pointers, j and then I. Okay. Now, is b equals to d? It's not. It's not. Okay. But still, we still haven't iterated through the entire string. Okay. What we're going to do is, we're going to increment it. Okay. Is c equals to d? No, it's not. But we have a option of cyclically increasing the value of c such that it becomes d, the very next value. If it's z, it becomes a. Now, since c is not a subsequence of d, since c is not equal to d, can I increment c, which makes it d? Now can I say that d is equals to d? Right. Sequence is present. Now I'll push both I and j. Now we've come out of the loop. Now since both of them are out of the loop, we can return that it is true. Okay. Let's take another example where it's not a subsequence. So A, B, and then let me take D. Okay. Here I have A and D. Is A a subsequence of D? No. If I increment A, it becomes B. Is B a subsequence of D? It's not. Let me increment this. Okay. Is B a subsequence of D? No, it's not. If I increment B, is it a subsequence of D? I mean, is it equal to D? No, it's not. So now we've come out of string 1. Now since we've come out of string 1 and string 2's length is not equal to since j, which is the pointer for string 2, is not equal to string 2's dot length, can I say that this is not a subsequence? You need to pay attention over here. So here, if you see, when I found the subsequence, I'm incrementing I and j. When it is a subsequence, your I and j pointer will always come out. So your j value will always end up being equal to string 2 dot length, if it is a subsequence. If it's not a subsequence, then your I will stay wherever it is and you'll be iterating through the entire your j will stay wherever it is because it's pointing to string 2, and you'll be iterating through the entire I, finding a value equal to j, right? So your j would never be equal to this length of string 2. Only when it is a subsequence, your j would also come out of the string, and that and it would come out of the string, and when it comes to the string, that length would be equal to the string 2's dot length. Because if you take 0 1, and so it will come to 2 is when it will break out of the loop, and since 2 is the length of the string 2, it is going to return me true. Okay, this is the approach. It's very simple. I'm not sure why this is named as a medium problem. It is a pretty simple problem. So let's try to code it, and I will explain it to you further during coding. Okay. Let me actually, yeah. Let's keep it very simple. Okay. Let's actually convert this to an array of characters. You don't have to, but I'm just doing it so that it becomes much easier to explain. Okay. So let me take a character array, and let me call it ARR1. Okay, ARR1. Yeah, ARR1. This will be equal to str1 dot length. Okay. Oh, sorry. To char array. To char array. Character 2 is ARR2 equals to str2 dot to char array. Done. Now I'll take 2 pointers, int I equals to 0, and then int j equals to 0. Okay, what I'll do is I'll run a loop while I is less than array1 dot len length and j is less than arr2 dot length. Okay, now I'm gonna check. This is a simple condition. If array1 of I equals to array2 of j, then I'm just gonna increment I and j. I plus equals to 1 and then j plus equals to 1. Else, if my ARR1 of I equals to z, I need to handle it, right? If I increment the ASCII value of z, it's not going to reach a, but it's going to reach the next character. So if you see over here, let me actually minimize this. Yeah. So if you see over here, we have z. What's good? The next ASCII value z. It's going to be an open bracket. So we can't do that, right? We need to make sure, we need to handle that condition as well. If it's z, what I'm checking is, I'm checking if ARR1 of I ARR2 of j equals to a. If it is, then again the same thing, I plus equals to 1, j plus equals to 1. Okay, else it's not equal, so I need to increment I is equals to 1. Okay, now else ARR, if it's not equal, what I'm gonna do is I'm gonna check if character of int of ARR of ARR1 of 1 of I plus 1. Okay, if it's equal to ARR2 of j. So here I'm cyclically increasing it, and then if it's equal, again the same thing, I plus equals to 1, j plus equals to 1. Okay. Actually, okay, yeah, screw it. Else okay, else what I'm gonna do is I'm gonna increment I. Done. Now here is a check that we are gonna add. If j equals to ARR2 dot length, then I'm gonna return true, else return false. there's so many things that you can write better, but I'm just writing it in a way so that it can be easily read. Right now I think it looks good. I plus one, check plus one, I plus one. Okay, perfect. So let's see, let's run it. So there's 3 pointers. Perfect. Submit. Perfect. We got a time complexity of n. I don't have the premium version, but it's of n. Okay. Thank you so much for watching. Thank you.